So we are to prove the limit of 1 minus cosine theta over theta as theta approaches 0 is 0. This is corollary to the previously proven theorem, which says that the limit of sine theta over theta as theta approaches 0 is 0. So first things first, we know that the limit as theta approaches 0 of theta is 0, and that the limit of 1 minus cosine theta as theta approaches 0 is 1 minus cosine 0 equals 1 minus 1 equals 0. So if you look at this would be the value of the limit of the numerator, which is 0, and the limit of the denominator is also equal to 0. So we will have 0 over 0, which is an indeterminate form. When we have indeterminate forms, it means we need to factor out the entity that makes, or we need to reduce the entity that make the numerator and denominator 0. So for this case, let us multiply the numerator and denominator by the conjugate of the numerator, or the conjugate of 1 minus cosine theta. This is to reduce the terms that approach 0. Okay, so the conjugate is 1 plus cosine theta. So when we do this, we get 1 minus cosine. So this is equal to 1 minus cosine squared theta over theta times 1 plus cosine theta. Now, what is this equal to? Recall from your Pythagorean identity that it is equal to sine squared theta. So, what can we do? We have sine squared theta, we have sine theta, we have theta. So, we can factor out sine theta over theta so that we can use the theorem sine theta over theta as theta approaches 0 equals 1. We have proven this previously. So, we get an equivalent entity or an equivalent form as the limit of sine theta over theta times the other sine theta, since this is squared, so the other sine theta over 1 plus cosine theta. Okay, to continue, we will apply the product law. So we will have, we will distribute the limit to the factors in the function. So we were able to separate or to factor out sine theta over theta as theta approaches 0, which has the limit that's equal to 1. For this case, we will evaluate directly. So we'll have the limit as theta approaches 0 of sine theta is sine 0. The limit of the denominator is 1 plus cosine 0. Sine 0 is 0, cosine 0 is 1. So we'll have 1 times 0 over 1 plus 1. This is 0, so we'll have 1 times 0, which is equal to 0. So therefore, the limit of 1 minus cosine theta over theta as theta approaches 0 is equal to 0. So as a recap, we were able to show that using the squeeze theorem, we can show that the limit of sine theta over theta as theta approaches 0 is 1, and we can use this to prove that the limit of 1 minus cosine theta over theta as theta approaches 0 is equal to 0.